Okay, so here is K-14 practice number 5's guide video. And this is a no calculator problem from the 2011 AP test. Okay, so let R be the region in the first quadrant enclosed by the graphs of f of x equals 8x to the third and g of x equals sine of pi x, as shown in the figure above on the test, but it's right here. Write an equation for the line tangent to the graph of f at x equals a half. Guys, we don't even really need this picture, to do this. What we want to do is know that we got to know that we got to use this formula. The equation of a tangent line to any graph at a certain number is this formula right there. Okay, so that's something we should have memorized. And then if you have it memorized, you could jump right to it. So it's going to be y equals, let me adjust this. Y equals, it's going to be f of a half plus f prime of a half, x minus a half. So now you just need to know f of a half and f prime of a half. So f of a half, you could plug 1/2 into this, or you could use the fact that, they're giving you this point, 1/2 comma 1, which is on both graphs f and g. And anyway, so if the x value is a half, the y value is 1, that means that f of a half is 1. You'd get the same answer if you plugged it in there. And then f prime of x is 24x squared. F prime of a half is 24 1/2 squared is 6. Okay, so now I'll go back over here. So y is equal to 1 plus 6 x minus a half. And I believe you get 2 points for getting that correct. All right, now for part B, we are going to find the area of this region R. Okay, and I colored this in already. And another thing I already did was I labeled which graph was which. All right, so you need a little bit of prior knowledge here. Like, you need to know that a sine graph looks, begins like this, and it's like a wave. Okay, so a sine graph is like a wave. So if you had that knowledge, you would know that this is the graph of g of x, which is the sine one. And a cubic, this part of a cubic kind of looks like that. So that would be f of x, which is the cubic one. All right, so anyway, if we're going to find this area, we've got to use top minus bottom or right minus left. Top minus bottom, you need everything in terms of x. Right minus left, you need everything in terms of y. And we're starting out with these functions in terms of x already, so hopefully top minus bottom will work, and it does. This region passes the vertical line test. So I go like this. Top, bottom. All right, so the top function is g, the bottom function is f. So the area is going to be equal to the integral from 0 to a half, top minus bottom. So the top is sine of pi x minus 8x cubed. Okay, now this is not a calculator section, so we can't use Math 9 here. We need to do the fundamental theorem of calculus, which is when you open up the brackets, put the antiderivative inside, put the endpoints, substitute in the endpoints and subtract. Okay, so in order to do that, I've got to use u substitution for this antiderivative, and then this one is pretty simple. So anyway, since I can't use the same technique, for both terms, I have to split it up. Shoot, that's minus. Okay, so this is the one I need u substitution for. So I'm going to let u equal pi x. So that's still going to be 0, but now this is going to be pi over 2. And then on the inside here, I'm going to have sine of u. Now, I need to have a du at the end there. So I got to substitute, I got to replace this dx with a du. So that's why you do the derivative over here. So du dx equals pi. Du is pi dx. Dx is 1 over pi du. Okay? So in for this dx, guys, is going 1 over pi du. But the 1 over pi is a constant, so you could write that out front if you want. And then that's just a du. Okay, let me bring this one down. Okay, now I'm going to carry down the 1 over pi, and I'll open up these brackets. The antiderivative of sine of u is negative cosine of u. The antiderivative of 8x cubed is 2x to the 4th. Okay, now I'll bring this down, and then I am plugging in the endpoints. Now, normally this is a minus, but since it's negative cosine, I'll do a plus. All right. Now, guys, actually, this one is just 0, and negative cosine of pi over 2, that is just 0 also. Cosine of pi over 2 is 0. So, I mean, you could do a little, like, unit circle. All right, pi over 2 is what makes us land here. And the coordinates are 0, 1. Remember, cosine is the x-coordinate, so that is actually just 0. The coordinates of this point here, so cosine of 0 is 1. So this is 1 over pi times just 1. Yeah, that's just a 1 in there. Minus, that is 2 over 16. So this ends up being 1 over pi minus an 8. Okay. Now for the last part, part C. Write, but do not evaluate, an integral expression for the volume of the solid generated when r is rotated about the horizontal line y equals 1. Okay, so the horizontal line y equals 1 is going like that. And I did do this picture here. Okay, so this is the region R. All right, this is the line y equals 1. And you're rotating this region R around y equals 1. And so when you do that, I'm not really a great artist, but my best shot is kind of like this. So I took the region and I just like reflected it over the line, and then I drew like this inner radius where the blank space is, and then like this outer radius that goes from the center of rotation all the way to the end of the region. And then I just like created circles. And yeah, so this is actually a washer. So the cross sections, you're gonna have like a solid shape, but the slices, the cross sections are gonna be washers. Okay. And you need to know that the area of a washer is pi big R squared minus little r squared. And in this case, for our radii, right, because this is little r, like this is little r right there, And then this entire, so that length, I guess, that would be big R. Okay, so when you're doing volume, let me move some stuff. All right, so volume in this case, and since the cross sections are vertical, this is going to be in terms of x. So x equals a to b, and then the area of a cross section in terms of x, okay, dx. Alrighty, now in this case, a of x is going to be equal to pi, and then we're going to have big R squared minus little r squared, and you've got to do top minus bottom for both of them. All right, so for the big R, top, so this is the top, and then that's the bottom. So top minus bottom is 1, all right, because that's y equals 1, is 1 minus 8x cubed, okay? Because this one here, remember that's 8x cubed from the, from that. And then for this little r here, top minus bottom is going to be, all right, so this is, I'll put a b here because that's bottom also. This top minus bottom is going to be 1 minus sine of pi x. Okay, so that would be the area, and then you just got to put it in the integral. And the endpoints, we're integrating with respect to x, so the endpoints are going to be from 0 to 1/2. And then this is pi. You could put the pi out front too if you want. Pi, a lot of parentheses, 1 minus 8x cubed squared minus 1 squared, close dx. All right, guys, there it is.